Our next example also involves two equations with two unknowns. We have this system of equations here that we're going to represent in augmented matrix form as shown here. And now our task is to apply Gaussian elimination to this system. And we do this in our first step. We need to perform elementary row operations on row 2 to make this -1 become a 0. What combination will do that? That's if we take half of row 1 and add it to row 2 and let that become our new row 2. So we just keep row 1 the same for now. 2, 3, and -1. And we replace row 2 with 1/2 of row 1 plus row 2, and that's what we enter here, and that makes this term go to 0. So we have half of 3 plus 1 is 3/2 plus 2/2, or 5/2. Our next term is 5/2. And then in the last column we have half of -1 plus -2. That gives us minus 5/2. And we're ready to now apply back substitution. This second equation tells us that 5/2 of y is equal to -5/2, or y is equal to -1. Now we'll use that piece of information and row 1 to say that this is really saying that 2x is equal to 1 minus 3y, and because we know y is equal to -1, we can use that information up here to say that 1 minus 3 times -1, or 1 plus 3, or 4. So since 2x is equal to 4, we know that x is equal to 4/2, or 2. So our solution is x equals 2 and y is equal to -1, and we can represent that as a solution vector of 2, -1. Oops, I didn't draw that very well. 2 and -1, and that's our solution vector right